Here's our practice worksheet for distance and displacement. We are going to draw and label vector diagrams to scale, okay? These are the scales. Either it's 1 centimeter equals 10 kilometers or 1 centimeter equals 10 meters. Depending on the problem, either I'll be meters or they'll be kilometers. So like this one has meters, this one has kilometers, okay? Step number, so that I'll show you guys how to do that vector diagram, okay, what a vector diagram is. You want to use color. You'll need one color. Now I recommend a pencil. If you have a colored pen, that's going to make it easier. I'm going to be using a red pen, okay, for my color. Okay, so we're going to draw the final displacement with the color, so you're going to need one color. And you're going to solve for the final displacement, and you're going to solve for the final distance. Alright, you need to be using math, not a ruler. That's to show your work. Okay, so how do we do this? First thing I need to pay attention to over here, right here on the side of the paper here, we have that north, south, east, west. This is called a compass rose. Okay, whenever we are dealing with north, south, east, and west, and we're drawing a piece of paper, north is up on the paper, south is down, east is to the right, west to the left, just like if it were a map. Okay? Alright, so here we go. Question number 1. A woman walks 30 meters south, then walks 30 meters east, and then 30 meters north. We need to start at the dot. Okay? 30 meters, according to our scale, that 1 centimeter is going to be equal to 10 meters. Okay? If I want to go 30 meters, so we're dealing with centimeters, and I want to go 30 meters south. Okay? So I'm going to start at the dot, and I'm going to go 30 meters south. Well, each centimeter is equal to 10 meters, so that would be 10 meters, 20 meters, 30 meters. Alright, going south, okay, looking at our compass rose, and I'm going to make that an arrow so that I can see that I went south. And it's 3 centimeters long, which represents 30 meters. Okay? And then we have, then she goes 30 meters east. Well, east is that direction. 30 meters, again, it's going to be 3 centimeters long. 10 meters, 20 meters, 30 meters. Now notice, this is a woman walking, so she walks 30 meters south and then 30 meters east. I didn't go back to the starting place and then go 30 meters east. That doesn't make any sense. Because she's down here, and now she's going to go east. And then she's going to go 30 meters north. Okay, so from this point where she is now she's going to go 30 meters north. So we've got 10, 20, 30 north. Okay, now whenever we're doing these vector diagrams, at the end we need to do the final displacement. Actually, let me get there one sec. Okay, distance. Distance, direction doesn't matter. Alright, it's just the length of the path she traveled. So the length of the path that was traveled, 30 plus 30 plus 30, distance is 90, and don't forget to give me units, meters. Now if you notice I've got a decimal point after all those numbers, that's just trying to do 2 significant figures. Okay, don't worry too much about it. So 90 meters, okay? That is the decimal there for significant figure. 30 meters that's the distance traveled. Now the displacement. Displacement is a straight line from start to end. Okay? So if you look back at your journal entry there on distance and displacement, okay? The distance is the winding path traveled. Okay? Displacement is a straight line from start to end. Okay? So if you want to even put that in here. From start to end, a straight line. Okay, well, you started at the dot, you ended right there. I need a straight line from start to end. This is what you're going to do in the color. Alright, so a straight line from start to end. It has direction, it is a vector, so we're going to draw it as an arrow. It's pointing at where you ended. Okay, it points at where you end. So this piece right here, this is the displacement. Okay, now how long is that displacement? Well, if you went 30 this way, 30 this way, 30 this way, north, south, east, and west, these are all right angles to each other. if this is 30 meters long right here, this must be 30 meters long as well. So my displacement is 30 meters, and the direction it is pointing east. We need to have direction. Remember your distances and displacement. Distance and displacement. Displacement has direction, east or left, or up or to the right. Distance does not have direction. Displacement does have direction. So each time you write down a displacement, you need to give me what direction it's going. Alright. A Border Patrol truck drives 40 kilometers north, then 20 kilometers west, then 40 kilometers south, and then 10 kilometers west. Okay, so start at the point. Remember, 1 kilometer is 10 centimeters, so there's our scale. I need to start going 40 kilometers north. Okay, so I'm going to go 40 kilometers north. It's going to be 4 centimeters long. So 10, 20, 30, 40. 40 kilometers north. Alright, you can even label if you want to, if that's helpful. Okay, 40 kilometers. Like this one was the 30, 30, and 30. Now this one's going to be 40. And then 20 kilometers west. West is that direction. But from this point, you don't go back to the dot. You start where you're at the point where they're at after that 40 meters. So 40 meters. And then from there, 20 kilometers west. So 2 centimeters, 10, 20. Okay, 20 kilometers west. And then 40 kilometers south. Okay, so from that point, 10, 20, 30, 40 kilometers south. And then 10 kilometers west. So going west again, that direction, 10 kilometers, that's just going to be 1 centimeter. Okay? Alright, so the distance is the path traveled, and the displacement is a straight line from start to stop. Okay? So right here, I want you to pause and see if you can figure out on your own. Okay? Okay. So, distance. Add them up. 40 plus 20 plus 40 plus 10. So 40, 60, 100, 110. 110, don't forget units, we're talking about kilometers. That's our distance, 110 kilometers. Okay? Now displacement. Straight line from start to stop. So this is where you started. This is where you stopped. Okay? Straight line from start to stop. Okay, an arrow pointing at where you stop. Okay, the arrow points at where you stop. So how long is that going to be? Well, again, these are all right angles. Okay, so this is 20 plus 10. 30 kilometers is our displacement. And what direction is it pointing? It's pointing west. So 30 kilometers west. Okay, so this is basically how you do the vector diagrams. Okay, I want you to try this one. All right, train travels east and then it travels west. Give me the distance, give me the displacement. Okay, remember, straight line from start to stop or start to end, that's your displacement. Pay attention to the direction the arrow is pointing. It points at where you end or where you stop. Okay, give these two a try as well. Okay, these are a little bit more challenging, but I want you to pause the video here. I want you to work out these problems, see how much you can do. Even if you can just draw the diagram, Draw it, check with your neighbor. Make sure your drawings match. Okay, make sure that you're doing it right. If you don't agree, then check and see who and discuss the problem with your neighbor so that you can figure it out. If you don't try, you're not going to learn. With these sort of problems, if you don't try to do it, you're never going to learn it. Just by staring at it, you're never going to learn. So please, 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 and by copying, you're not going to learn either. And you have to be able to do these for the quiz. So, pause, work the problems, and if you need to, and I would say recommend, work with your neighbor. Alright? That's how you're going to do your best on this. Work with your neighbor. So pause now. Okay, so working these out. So you know how to do these. Okay? Train's going to travel 110 kilometers east. Okay? So our little compass rose. Draw one right there so we can see what's going on. 110 kilometers east. Well, if every centimeter is if every centimeter is 10 kilometers, I need to go, let's figure out how far I gotta go. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. 110 kilometers east. Okay? And then I go 80 kilometers west. So going back 10, 20, well think about it as a train, okay? It's on the same track. So you're going to go back on that same line. 10, 20, 30, 40, 50, 60, 70, 80. Alright, so 8 centimeters backing up. Make it a little arrow pointing west so that you know that 80 is going west. So 110, this one's 80. Alright, what's the distance? Alright, the train went from here all the way to there and then to there. How far did the train travel? Well, 110 plus 80 gives us 190. So that's your distance, 190 kilometers. Direction does not matter. Now displacement. Displacement is a straight line from where you started to where you stopped. Okay, so from start to stop, a straight line. Remember, do your displacement in color. Straight line from start to stop. Arrow pointing at where you stopped. How long is that arrow going to be? Well, instead of getting your ruler and measuring it, let's do some math. If this is 110 kilometers and this is 80 kilometers, how much do we have left there? Well, 110 minus 80. Alright, that's how we would do the math for that one. You get 30. So my displacement, 30 kilometers. Direction it is pointing east. 30 kilometers east. Okay? Alright. The security officer, number 4. So check your work, make sure you do it right. Okay, security officer goes 10 meters east, then 20 meters north, then 40 meters west, then 20 meters south, then 10 meters east. Wow, that's a lot of walking around. Well, security officer, that's kind of what they do. Alright, so 10 east. So from here, 10 east, and I'm going to label these as I go so I don't get lost. Then 20 north. Okay. 20 north. 40 west. Okay, from that point, 40 heading west. And then 20 south. And then from there, oops, I measured that one wrong, didn't I? Yes, I did. Haha. Alright, so I just realized I made a mistake on that one. This one was supposed to be longer, so I'm going to start over. I didn't measure right, so pay attention to your measurements. I was going too fast. 10, because if you don't draw it to scale, then it's not going to make much sense. 20, I only did 1.5 centimeters instead of doing 2 full centimeters like I should have. So it didn't work out right. Okay, so 10, 20, 40, then 20 south, and then last one, 10 east. Okay, so notice I'm using use your compass rose if you don't know your directions very well. That's perfectly fine. Just make sure you get it right. Okay, and 10 east. Okay, so to figure out my distance, I just add them up. So 10 plus 20 plus 40 plus 20 plus 10. Okay, add them all up. Doesn't matter which direction they're going. You just add them up for the distance. So 1 plus 2 plus 4 plus 2 plus 1. Well, that's 20, 40, 80. That makes 100. 100 meters. Sorry, meters. Pay attention. Meters. Let me wipe that out right there. Pay attention to your units. Read the question carefully. Talking about meters. Okay? So 100 meters. That's your distance. My displacement. Alright? Where did I start? Right here. Where did I stop? Right there. Straight line from start to stop. Arrow pointing at where you stopped. Okay? How long is that? Well, you can pull out your ruler and figure that out. Or you can look at this. If this is 40, this piece is 10, and that piece is 10, that piece should be 40 minus 10 minus 10. Do the math here. 40 minus 10 minus 10 is 20. Sorry, I should have written that in red. 20 meters is my displacement, but I need direction. What direction is that pointing? West. Okay. Question number 5. Motorcycle does 30 west, then 40 south, then 10 kilometers west, then 10 kilometers north, and then 40 kilometers east. All over the place. All right. 30 kilometers west. 40 kilometers south. Make sure you keep them in order. Okay? 30 west, then 40 south, then 10 west. So going this direction. Then 10 north. If you need to, as you do them, you can mark them off. Or you can label them so you can keep track. And then 40 east. Oops. Just there. 40 east. So, for my distance, I just got to add them up. Doesn't matter what direction they go. So 30 plus 40 plus 10 plus 10 plus 40. Add them up for my distance. 4 and 3 is 7, 8, 9. 9 plus 4 is 13, 130. 130 kilometers. That's my distance. My displacement. Straight line from start to stop. This is where I started. This is where I stopped. Straight line. Make it an arrow pointing at where you stopped. Okay? So, start to stop. My displacement. This piece right here is 40. It's parallel to that one. This piece is 10. It's also parallel. So if this is 40 and this is 10, this piece is going to be 30. Okay? So it would be 40 minus the 10 gives us 30. There's your math. Okay? 30 kilometers, and the arrow is pointing south. Okay, so distance versus displacement in these vector diagrams. Okay, so all the ones we've been doing have been all nice straight lines, a nice east, north, south, east, or west. Okay, 90-degree angle turns. Other side. Okay, the Pythagorean Theorem at the top there, little information there. Rearrange to solve for the hypotenuse. There's a formula that you're going to be using. Important formula. Okay. We have a boy. He walks 110 meters east to his friend's house, then he walks 150 meters west to his cousin's house, and then 80 meters east to the cute girl's house. Alright, well, let's write up his path. Let's draw it up. East, let's draw up here our little compass rose, just so we can have it north, south, east, and west, so we don't make any mistakes. 110 east. We did 110 already. We know that's 11 centimeters. 10 centimeters, sorry, 1 centimeter for every 10 meters. 11 centimeters. That would be 110 meters. Okay? Now that's his friend's house, right there. Then he's going to walk 150 meters west, so the opposite direction, 150 would be 15 centimeters. He's going to walk back the exact opposite direction, 150. Okay, so then you have 150. 110 going that direction, 150 going that direction. And now he's at his cousin's house. Right here. And then he has 80 meters east to the cute girl's house. Well, east, going back the opposite direction again. 80 meters, going to be 8 centimeters from his cousin's house to right there. So we did 80 meters that direction. Okay, so what is his total distance? Done a lot of walking. 110 plus 150 plus 80. Okay, you just add them up. Add them up, add them up, add them up. So 1 plus 5 plus 8, that's going to be 14. 340 meters is going to be his distance. Okay? Now, displacement, straight line from start to stop. If you look at this diagram, you have no idea, just by looking at it, where on earth you started and stopped. So you're going to want to label these. Start, where did you stop? Did we stop here? Did you stop there? Or did you stop there? Stopped right here. Okay, straight line from start to stop. I'm drawing it nice and dark so you guys can see that. Okay, straight line from start to stop. Make it an arrow pointing at where you stopped. Okay, how long is that? It's a good question. How would you figure that out? Well, here's your little helpful hint. Notice the east, 110 east and 80 east, and then west. You add them if they're going the same direction. You subtract if they're going the opposite directions. So, for the displacement, I'm going to do 100, or you can do it this way, 110. Went the opposite direction, so minus 150. And then you went back and east, so plus 80. Okay? So that's what you ultimately need to do. Easier thing to do is 110 plus 80. Those are both going east. That gives you 190. And now you're going to subtract the 150 because it's going west. 190 minus 150 is 40. Okay? So 40 meters. Okay? Now what direction? Well, if you drew the arrow in here, you can see it's going east. But if you don't want to think about the arrow and you just want to look at the math, if you notice 190 east is a bigger number than the 150 west, so east wins. 140 east. There you go. Sorry, 40 east. So that's number 6. Okay? Number 7, 8, 9, and 10. These all require the use of the Pythagorean theorem. And each one of these you're going to be solving for the hypotenuse. Okay, so quick little review here. When you have a right triangle, right degree angle right there on that triangle, this third side over here, the side opposite the right triangle, this is the hypotenuse. That's C. This is A and this is B. Okay? C, the hypotenuse, that is going to end up being your displacement in each one of these. The one in red. So each one of these you're going to draw up the diagram and then you're going to have to figure out that displacement. Okay? Calculate it using this formula. C is the square root of A squared plus B squared. Alright? If you don't know how to do that in the calculator, at least do each diagram, set it up, set up the formula, and then you can see in the video how to do those examples. Okay? So make sure you have that there. And I want you to do 7, 8, 9, and 10. So pause, work those problems out. If you need to, you can use a neighbor. But I want you to try 7, 8, 9, and 10. You have to use the Pythagorean theorem on these. Okay? If you don't have a right triangle, then you drew it wrong. So pause the video now and get those done. Work with a neighbor. Okay. So, working through these. Oh, sorry, this one does not require the Pythagorean theorem. Sorry. North, south. My mistake. 50 kilometers north. Then 20 kilometers south. 50 going up. 20, that little piece right there. Straight line from start to stop will be your displacement. Okay, so the distance, add them up. 50 plus 20 gives us 70, looking at kilometers. And displacement, this is 50 and that piece is 20. This piece is going to have to be 30 kilometers and it's pointing north. Okay. This one definitely uses the Pythagorean theorem, number 8. Okay, 40 meters south, 4 centimeters. Then 80 west, 8 centimeters. Okay, so my distance is simply going to be 40 plus 80. Gives us 120. Dealing with meters, so that's our distance. For displacement, straight line from where you start to where you stop. I should clarify this one as well. This was the start, this was stop. Okay, straight line from start to stop. Now this is where you're going to be tempted to just use your ruler and measure it. But I need to see your math. Okay? This is where you need to use the Pythagorean theorem. Okay? To figure out your displacement, you need the Pythagorean theorem. Alright? Which states, and we're going to use it organized like this. So we're trying to solve for C, which is the hypotenuse right there, our displacement, and it's the square root of a squared plus b squared. Alright. A 40 squared plus b, side b, 80 squared. Alright, now, putting this in the calculator. This is what you got to know how to do this. Let's put this in the calculator. Calculator's on. Okay, the square root symbol. Okay, hit the second button and come down here. You see that square root symbol, the x squared? Above that, the square root. There's square root. Okay, now type in the 40, and that same button without the second gives you that squared. Okay, it's the button right next to the 7 there. Okay, plus, and then do 80, and then again squared. Good habit, close the parentheses. So this is the same thing. Square root of 40 squared plus 80 squared. Enter. Calculator says 89.4427 blah 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 significant figures, 2 significant figures. So my displacement is 89 because that 4 does not round the 9 up. So 89, and we're talking about meters. Now what direction is that going? Alright, well, looking at a compass rose, okay, it's not going south, it's not pointing south, it's not pointing west, it's pointing in between south and west. So we just say southwest. Okay? Alright, number 9. 50 kilometers south, and then 30 kilometers east. 50 south, 5 centimeters going down the page, 3 centimeters east, 3 centimeters to the right, my distance is simply 50 plus 30, so 80 kilometers is the distance. Displacement, straight line from where you start to where you stop. Okay. Arrow pointing at where you stopped. How long is that arrow? Tempting to measure it with a ruler, but I need you to use the Pythagorean Theorem because we have here a right triangle. Okay? So C is equal to the square root of A squared plus B squared. A and B are the lengths of our two sides. So C is equal to the square root of 30 squared plus 50 squared. And honestly, it doesn't matter which is side A and which is side B. You still get the same answer. Okay? So, again with the calculator, you're doing square root. Okay? So, square root is that second symbol. Okay? Right there, the x squared, hit the second symbol and then the x squared to get that square root there. And then type in your number, 30. And then that same button right next to 7 squared. Puts a little squared up there for you. And then plus 50. Same button for the squared. Okay. And then close the parentheses, good habit. Enter. Alright, so our hypotenuse, or our displacement, is 58.30951, blah, blah, blah. Oops. Okay, and so give that numbers, significant figures, just 58, 2 significant figures. We're dealing with kilometers for units. And what direction is the arrow pointing? Well, if you look at the compass rose, it's not going south, it's not going east, it's in between the two, so we're going to say southeast. Okay? Alright. Number 10. We've got 60 kilometers east, west 40 kilometers, and then south 40. So, east 60, so 6 centimeters. From there, west 40. So from that point, we need to go backwards 4 centimeters. So west 40. And then south 40. Okay, so for my distance, 60 plus 40 plus 40, add them up, you get 140. Kilometers are units, so there you go, 140 kilometers. Displacement. This is where we start, this is where we stopped, straight line from start to stop, arrow pointing at where you stopped. Okay, how long is that? Well, we're going to need, we have here a right triangle. So we're going to use the Pythagorean Theorem again. So C is equal to the square root of a squared plus b squared. Okay, so C is equal to, what are my two sides? Okay, well, here's one piece of the triangle, and here's the other piece of the triangle. This piece, that one's obviously 40. So 40 squared plus, how about this piece right here? Is it 60? This is 60. This is 40. How big is this piece right here? 60, 40, 20. So 20 squared is the other side of that triangle. Okay, so that right there, it's very important that you're paying attention. You don't just randomly just plug in one of those two numbers just because you think that's it. You have to pay attention. That's 60, that's 40, this is 20. So that's the side that, let's link that triangle. Side of that triangle. Alright, so using Pythagorean Theorem in your calculator, second button, so we can get our square root, 40 squared plus 20 squared, close the parentheses, good habit, enter. Our hypotenuse, or displacement, is 44.721359, blah, 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 blah. Significant figures, we want two significant figures, but that's 7. So going around that 4 in the ones place up. So it's going to be 45 units, kilometers. Arrows pointing south and east. So southeast. And there we go. That is the worksheet. You need to be able to do these sort of problems, these diagrams, and identify the calculate distance and the displacement. You need to be able to use Pythagorean Theorem, and that is all on not only the quiz, but it is also going to be on the CBA. Pythagorean Theorem doesn't actually have the CBA. Pythagorean Theorem CBA questions on distance and displacement are more like these, but you do need to be able to use the Pythagorean Theorem. That's something that in life is good to know. Alright, so once you have this worksheet done, we're going to glue it into the journal. Okay, so in your table of contents, distance and displacement, practice worksheet. It's going to be glued in on page 4. Okay, so find your page 4, distance and displacement. This is our first time gluing in a full-size worksheet. Okay, so take your worksheet. Okay, we're going to put the glue in the binding again. Okay. Right there in the binding. Tuck in the worksheet, put it front side up, the top of the page, into the glue. Okay, now close your journal. Squeeze that edge. Notice I'm leaving the page out. Okay, So I'll give you guys a slightly larger view of this. Notice I'm letting the page stick out. Okay? Give it its 15 seconds. Let it sit for its 15 seconds. And then what you do is you take that page and you just fold it so that it stays in. Okay, you fold it and tuck it in like that. So this is what your distance and displacement is going to look like in the end. And that worksheet is now a part of that page. So your notes and your practice are all together in one section right there in your journal. Page 4. Distance and displacement. Everything you know about distance and displacement for the quiz is all right here. You do need to know this sort of stuff. You need to be able to understand this. Go over this again. You need to be able to understand the diagrams, and you need to know this information as well. You need to know these facts. All of that shows up on the quiz for distance and displacement, and that quiz should be tomorrow.